Alright guys, now we're gonna do problem 1511 on the for dynamics, and the problem says that this small block right here weighs 19 pounds and is placed on the syncline, and then two forces act on this block, which is a 6-pound force and a 15-pound force parallel to the line AC and the lines AB. So if the block is at rest, we gotta determine its speed after 4 seconds, and the coefficient of friction UK is 0.2. Well, this problem is kind of long and confusing, but I'll try to make it as simple as possible. First of all, we're gonna need to draw some free body diagrams so you guys can understand. So let's see. First, if we look at this from the side, we're gonna see that the free body diagram looks something like this, right? And you got a 15-pound force, the weight, the normal, and now that you got this, there's something you need to note. Notice how the weight kind of opposes the force, but the question that you're gonna ask yourself is which one's gonna win. In other words, if the weight wins, then this thing's gonna move down, but if the force wins, then the block's gonna move up. And this is important to know in what direction the friction force is going. So if we get W sine of theta, you're gonna get that is equal to 9.5 pounds, and 9.5 pounds is smaller than 15 pounds. Therefore, the motion is up and the friction acts down. So these are all the forces when you look at it from the side. Now if you look at it from the front, this should look something like this. Sorry, I'm drawing it so small, guys. It's just that we're gonna need the space. Now we got this force, which is 6 pounds, and it's very obvious that friction is this, sense motion is towards the right because there's no other forces opposing the 6-pound force. Alright, let's just do something this way. Sorry, that's supposed to be parallel to the is the X, and that way is a Y. That way you better understand it, right? So this is the Y component of the friction, and this is the X component of the friction. Alright, now that we got all this information, we're gonna see what we're given. We're given the weight of the block, which is 19 pounds. We're given a force that acts on the X direction according to the diagrams I just drew, which is a 6-pound force. F on the Y, which is a 15-pound force. An initial velocity of 0 because the block is initially at rest. A delta T of 4 seconds. Coefficient of kinetic friction of 0.2. And an angle of 30 degrees. This is what we're given, right? All right, let me go over here now. So basically what we're gonna do is we're gonna do two equations and solve for the final velocity, which is what we're trying to find out. Now, you know that motion is up and motion is to the right. Therefore, the motion is gonna be in this direction, more or less, you know. The motion is gonna be in this direction, and this angle we're gonna call it phi. And if the motion is in that direction, then the friction, which opposes motion, is in this direction. That's important for you to understand. So let's say we're working with the x, which is this diagram. Alright, so forget about this, let's look at this diagram for now. We got the mass times the initial velocity plus the sum of the integral of the forces over time equals the mass times the final velocity. If we plug numbers in, we know that this is 0 because again it's initially a rest. Now let's gonna work with the forces. We got 4 times the force in the x directions, which is a 6-pound force, minus 4 times the friction in the x direction. And all of that is equal to the weight, which is of course 19 divided by 32.2 because we're looking for the mass, not the weight, times the velocity in the x direction. So we plug some numbers into this equation, you know, we get something that looks like this. First of all, notice something. The friction is equal to the cosine times phi of the friction on the x direction. Alright? And the force in the x is the force in the x. Alright, so we get 24 from here minus the friction force, which we have to figure it out. Okay, let's figure out the friction force. The friction force is equal to the coefficient of friction times the normal, which we can figure it out from this diagram. And we know from here that the normal is equal to the weight. Yes, that's the weight, yes. The weight times the cosine of 30 degrees. And with that, the normal comes out to be 16.5, which makes the friction 16.5 times 0.2, which is the coefficient of friction, which makes it 3.3. That's in pounds. This is in pounds as well. So now that we got the friction, we know that the friction, which is 3.3 times 4 times the cosine of phi is equal to 0.59. Now this is the same thing with the velocity. If the velocity is going to be moving in this direction, and this is phi, that will be times the velocity times the cosine of phi, because the x component of the velocity is the velocity times the cosine of phi. See, here I do the diagram for you guys. Let's make that a phi. Okay, so if we simplify this, in the end we're gonna get 24 equals the cosine of phi times 0.59 times 0.59 V plus 13.2. This is gonna be our first equation. Now let's do our second equation, which will be same basic procedure but on the y. We have the mass times the velocity initial plus the sum of the integral of the forces over time is equal to the mass times the final velocity. Alright, now you know this is 0. So what are the forces acting here on the y direction? Remember, this is the y. So let's see, we got the 15-pound force going upwards, the friction opposing it, and part of the weight is opposing it. So we're gonna get something that looks like this. Let's see, the 15 times 4 minus 9.5. Let me make that more clear. 9.5 times 4. The 9.5 is the y component of the weight, in case you're wondering where that comes from, minus the friction, which is 3.3 times the sine of phi, because in the y component of the friction would be this. The y component of the friction is the friction times the sine of phi, times 4, and that equals 0.59 times the y component of the final velocity, which would be times v sine of phi. Now we simplify this equation. In the end, we're gonna get 22 is equal to sine of phi times 0.59 v plus 13.2, and this is gonna be equation 2. Now we're gonna get to the answer. If you divide equation 2 over equation 1, divide this by this, and you simplify, you're gonna get that the tangent of phi is equal to 0.917. Therefore, phi is equal to 42.5 degrees. Watch those significant figures. And knowing phi, we just plug in phi into one of these equations, and we're gonna get that the final velocity, which is what we're looking for, 32.8. I think if you plug it into equation 1, it gives you 32.8, and if you plug it into equation 2, it gives you 32.7, but it's basically the same answer, it's just significant figures of kind of problem, but it doesn't matter. This is the final answer, and this is in feet per second, and that's the answer.